SV Math Teach back again. This time we're going to work on the second video in Pythagorean Theorem. And that one's going to help us use the Pythagorean Theorem to determine if a triangle is a right triangle. In the first video we talked about how each triangle in the Pythagorean Theorem has to be a right triangle in order to work. Well, what happens if we get a question like this one, right? We get a triangle, it's clearly a triangle, but I don't know if it's a right triangle. There's no markings anywhere. And while I could probably eyeball, I mean, this is never really a good mathematical strategy, but I can kind of look at those two and say, well, they don't even look like right triangles. We're not really supposed to trust that, but most of us do anyway. But this side up here, I don't know, that kind of looks like it's a right triangle. So is it? Well, this is an application of the Pythagorean Theorem. And I'm going to show you how this works. Now, a reminder that the Pythagorean Theorem is simply a squared plus b squared equals c squared. And a and b should be your two legs, or the two sides that make up the right triangle. Now, while I strongly suspect that if this is a right triangle, this and this would be my leg, remember, I'm not really supposed to assume anything. That's bad mathematical strategy. So instead, I made this pro tip down here. You always want to assign the longest side the c value. And if you don't know which side the longest side is, that's why I have this calculator here. So there were three sides that were given to us. There was 5, which is just 5. There was the square root of 30, which is approximately 5.47. And there was the square root of 55. The square root of 55 is 7.42. So of these three sides, I don't know what A and B are. I know they're interchangeable, but I know this is side C. So I'm going to go ahead and place this number in the side C spot. And I'm going to place the other numbers in the A and the B spot. It doesn't really matter where they go. I'll put the 5 and the square root of 30 here. And now all we need to do is find out, does this work? If it works, that means it satisfies the Pythagorean Theorem. If it satisfies the Pythagorean Theorem, then we have a right triangle. So let's do this. 5 squared is 25. 5 times 5 is 25. The square root of 30 times the square root of 30 is 30. Kind of cool, huh? And the square root of 55 squared is 55. So we add these two together, 55. On the other side, we already have a 55. This equals, I'll put a little check mark up there, maybe even a little bit of smiley face, and I would say, yes, it is a right triangle. Okay? That's how that works. You take the two small sides for A and B. You take the longest side for side C. You just see if it works. If it works, it's yes. It's a right triangle. If it doesn't work, it's no. Second example. This one says a triangle has side lengths of 15 inches, 8 inches, and 10 inches. Is it a right triangle? No picture this time, but it does give me 15, 8, and 10. Now these are all just whole numbers, so I could pretty easily see that 15 is the longest one. So 15 goes here. The 8 and the 10, they go in the other two places. Once again, doesn't really matter where. I'm doing this step. I substituted my numbers in. I remembered that the longest side is side C. Now, if it works, it's a right triangle. So here we go. 8 times 8 is 64. 10 times 10 is 100. I add those together, I get 164. 15 squared, 15 times 15, if you haven't memorized that, is 225. And I think that means it's not going to work. Look at that. 164 and 225 are not the same. They are not equal. So none of these things are equal. That means the Pythagorean Theorem did not work. So not a right triangle. Okay? And I'm not sad about it. I'm not going to put a frowny face or anything because this isn't bad. It's just not a right triangle. So we use the Pythagorean Theorem to either determine whether something is or is not a right triangle.